Today's lesson is 6.2, notes on areas under the standard normal curve. And our goal today is to be able to apply properties of the normal curve to make predictions about quantitative data. So you can recall from lesson 6.1 that we talked about the normal distribution. We talked about the flatter the curve, the larger the standard deviation, and we talked about some key factors of the standard normal curve and the ways that we can move past just our basic 68, if you recall the 68, 95, 99.7% rule. We can figure out those values for any normal curve. However, right based on the plus or minus 1 standard deviation, this goes back, plus or minus 2 standard deviations back to unit 3, and then plus or minus 3 standard deviations. So we can figure these out based on any data set. However, we can't find percentages of or probabilities of values or data points within a given data set and the associated percentages beyond these 3 until we convert everything to this standardized version. So we got the taste of this. We talked about the standardized variable z, where we take any x value, subtract the mean, divide by the standard deviation. So we can basically convert any value in a data set to its standardized version. And then what we're going to learn today is how to use that standardized variable to calculate an area under the curve using this z-score table in our text is called table 2. So that's kind of an overview and refresher on 6.1. It's been a while. So again, refresher, property 1 about the standard normal curve. The total area under the curve is 1. Secondly, the standard normal curve extends indefinitely in both directions, approaching but never touching the horizontal axis as it does so. Again, you see here there's still a little bit of space between the horizontal axis and this curve. The standard normal curve is symmetric about 0. That's huge, right? Half the area is to the left of 0, half the area is to the right of 0. So you have a 50-50 chance of landing on either side of 0. Almost all the area under the standard normal curve lies between -3 and 3. Again, all of those should be refresher. So now we're going to determine a percentage or probability for a normally distributed variable. These are the steps, and then we'll apply them in the examples to come. Another way to think about the percentage or probability is the area under the curve. So I wrote that little note, how to find the area under the curve. These 4 steps apply. These are all parallel concepts. So step 1, you want to sketch the normal curve associated with the variable. Step 2, shade the region of interest and mark its delimiting x values. Step 3, find the z-scores or z-score for the delimiting x value or values that you just found. And then step 4 is use the table 2. You'll get a copy of this table here to find the area under the standard normal curve delimited by the z-scores found in step 3. All right, so take just a quick note. Again, refresher from 6.1. We learned that we can obtain the percentage of all observations of a normally distributed variable that lie within any specified range by first expressing the range in terms of z-scores. And second, just here in 6.2, determining the corresponding area under that standard normal curve. So this is where we'll implement that second step. The first and most basic way to find area under the curve is to the left of the specified z-score. We will also talk about finding areas to the right of the specified z-score, as well as areas that are between the two specified z-scores. So here goes. The question asks us to determine the area under the standard normal curve that lies to the left of 1.23, okay, as shown in figure 6.9. So you have this figure. This would be the one that you would draw, but it's drawn for us. I'm going to make a note of that just so you keep in mind that this is part of the process. This is step one of the process, is to draw, but it's drawn for us. Next step is shade the region of interest and mark its delimiting x values. The x value has been converted to a z-score. So it's kind of step 2 and 3 in 1 combined. So you can see how this z-score of 1.23 has been marked, and the area of interest has been shaded. It's to the left. And then in step 4, use table 2 to find the area. I'm going to show you how this works. It feels like a lot at first, but then I think you're going to enjoy this lesson, because once you get the hang of this table, it's actually pretty simple. Notice I have two sides, okay? There's some things you'll notice. Z-scores are positive on this side, and you'll notice that the z-score in the picture is to the right of 0. Okay, these are to the right of 0 is positive. Makes sense. On the other side, you'll notice all of these values are negative, and the random z-score over here is to the left of 0. Again, makes sense. But this is the negative side. But notice too that both have area. The default is shaded to the left. Both sides, shaded to the left. Okay, that's why. Shaded to the left is first, area to the left, it's the simplest one. So I'm going to find 1.23 is positive, so I'm on this side. I'm going to go to 1.2. Notice it says z right here. So I'm going to look for my z-score. I go down this side first, or this column. I find 1.2, and then see how it says second decimal place? So this is the first decimal place. The second decimal place is here, is 3.03. So I'm going to line those up, and 0.8907. Some people who have, it's really tiny, feel free to use some papers, or I think paper, probably easiest, to help you navigate. Oh, there it is. Like, here's the 0.03, here's the 1.2, so that where they meet is the area under that curve. So 0.8907 would be the area underneath, or to the left of 1.23. Next one. We'll do some more examples like this at the end. So the next one is area to the right of a specified z-score. This requires one additional step. We know that the total area under the curve, recall, this is property 1, it's right up here. Area under the curve it's 1. So if I have an area of part, then the other part would just be 1 minus that area. So if I find the z-score of 0.76, I'm going to go find this, 0.7, I have trouble writing these up, so I like to use the papers, 6. So that's going to be a 0.7764. So I'm going to write that down. That would be the area to the left, right? 0.7764. Simply, to find the area to the right, I do 1 minus that. not hard, 0.7764. 1 minus that. And you'll see that this is actually done for us underneath my Post-it note, which is on your paper. That would leave us with an area to the right of 0.2236. And that's how that works. Area to the right. You can see it's helpful. It's helpful to draw the picture, just to help remind you which, if you're doing the 1 minus, or if you're not, if you're just doing the regular to the left. Now here's this next option, which would be area between two z-scores. So you can see here, we will actually look up both of these values. The area to the left of 1.82, I'm going to start there. It's a positive 1.82, so I'm going to find 1.8, and then the 2, line them up, 0.9656. I'm going to write that down. So that means the area to the left of here, I'm going to highlight that. That's all of this, right? That's all of this. Now I forget what I just saw. So it's 0.9656. All of this yellow area is 0.9656. And then to the left of 0.968, negative 0.68, like I said, negative 0.68, I find negative 0.6 right here. And then the 0.8 at the top. Just it out to the edge. Line those up, and you can see 0.2483. So 0.2483 is going to be just in this part right here. Right? So it would make sense then, hey, subtract the orange from the yellow, and you'll get just this part right in here. So you can see that's done right here. The area in just this region is the 0.9656. That's all of the highlighted yellow, minus the orange highlighted yellow is going to give you that region in between. So this is, I would say, there 3 steps. But whenever you're talking about between, you think about 3 steps. Step 1, find each one of the areas. So find area 1, and then area 2, and then subtract. Not complicated. It just requires 1 extra step. So in summary, shaded area to the left of Z is what it is. It's what you find on the chart. Shaded area to the right of Z, 1 minus area to the left. And shaded area in between is going to be area to the left of Z2 minus area to the left of Z1. I like this little summary. I think it's helpful. Next up, we have some practice questions here. And you're going to use that same process to find each one of these values. I want you to practice doing that on your own. Pause now and then come back and check your answers. As always, if you have questions on any of this information, please, please, please come and ask me questions. I am glad to help. And I think asking that question can save some frustration. I think that this is once you get the hang of it, like I said, fairly simple process. So pause now and try these questions. All right, hopefully you've had a chance to check these out. I did go ahead and cross these 2 out. If you wanted to try these, you'll notice there's 3 decimal places. I would just round to 2 decimal places. So this one would be negative 2.01. If you wanted to give those a try, but just for now, for this first problem, maybe we'll call it A, is 0.975 to the left of 1.96. Question, we'll we'll call it B in case you wanted to try it, and then we'll call this C. So we need to subtract 0.8413 minus 0.1587 and get 0.6826 as the area. Again, that's associated with the probability. Okay, so we'll look at the applications of this a little bit more in section 3. So this is, I already canceled that one. That's D, if we wanted to call it. So, can kind of ignore that. So then this is E. Found these two. So 1 minus 0.8997 is 0.1103. Like I said, 0.1003. And lastly, this is a good one. I really like this one because it reminds us we can look at the area to the left of 0. We can look that up on here. But we should know it based on our properties. Symmetric about 0. We talked about the area to the left and to the right of 0 is the same, 50-50, half and half, 0.5, 0.5. So you'll also find on your, if you want, if you forgot, it's 0.5. You'll find it on here as well. So we're just finding the area to the left of 1.54, which is 0.9382. Area to the left of 0 is 0.5. Subtract the 2, we should get 0.4382. There you go. There's some more practice problems. I think that it's great to do practice with this. Like I said, the more you practice, the more you become familiar. So pause now and try a few more practice problems. Welcome back. Here is question number 7. I've circled the symbol here. Less than, remember this is less than, that would indicate to the left. So we're looking at the table and we're simply looking up 1.35 and you'll see 0.915. Same thing here, less than. This will be on the negative side, right? But 0.4286. Notice all of the ones that are negative should be less than 0.5. And all of the ones that are positive z-scores should be greater than 0.5. That's kind of a good little trick to make sure. Now here it's greater than, so find the area to the left of 2.358. I rounded that to 2.36. And then found 0.9909 and subtracted that from 1 to get 0.0091. So we have here 11 is done for you, and then I'll do number 12 with you, which step 1 is to sketch. I think sketching especially comes in handy when you're dealing with between two values. I put the 0 in the middle. I go, okay, 1, 2, 3. Just get my bearings here, and then find the negative 1.2 is going to be somewhere around here, and then we have the 0.18 is right about, well, I was way off. 0.18 would be closer to 0, so pretend that's a little bit over here. This is 0.18, and so these are those delimiting z-scores. I'm going to draw that I want the area between the two. What should I do? Look up each one of these and subtract. Subtract those areas. I'm on number 12 first, though, so I'm going to just look those up first. 0.18 is 0.1, look over to 8, it's 0.5714. 0.5714 minus, flip it over, the negative 1, sorry, negative 1.2. So negative 1.2 is here, and then I go to 0. Okay, there's not another decimal place, so I go to the 0 column, negative 1.2. We land at negative, or 0.1151. So type that in. 0.5714. 0.5714 minus 0.1151 is 0.4563. 0.4563. All right, this next one, question 13, we can do 0.56, look that up, look up negative 0.23, try that one out on your own. I do expect that to be filled in for a notes check, so make sure you don't skip over number 13. Do this on your own. Okay, there is one more piece to this type of question, and that is the reverse. What if we're given the area and we want to figure out what is the z-score? So there's a special notation called z sub alpha notation, the symbol z sub alpha. It's really teeny tiny. It's a little bit bigger. I'm going to make a z sub alpha. So it's a subscript there. It looks like a little fish. It is used to denote the z-score that has an area of alpha to the right. So we're switching it up a little bit. Under the standard normal curve. We're cool with that though. We can go either side. We just know it's 1 minus to find the other side. So this is how it's said in case you forget. So then to do this, we're going to look up the area of this region right here. The notation gives us the area to the right. How do we find the area to the left? 1 minus. So I'm going to do 1 minus 0.025, and that gives me 1 minus 0.025 is 0.975. 0.975, I can look that up in my z-score table. Bigger than 5, or bigger than a half, right? So I'm going to look on the positive side, 0.975. I'm going to look in this region now. These in this region are the areas, right? So I have to find 0.975, 0.975, here it is. I don't encourage you to write in marker on this, but I just did. So that would be 1.96. The z-score, you just trace back over, 1.96. So z equals 1.96. All right, let's try it again. Area is 0.05. We can write that in z sub alpha notation as z sub 0.05. What's the area to the left of that? 1 minus 0.05, which is just 0.95. That's this area. That's the one we can find on the chart. So I'm going to go back over here. 0.95, it's got to be close to here, 0.95. So that's right here where we've got halfway, I mean it's really halfway between these two. So we would say that we go over to 1.6 and then we go up to the top. Halfway between the 4 and the 5. So it's 1.6, halfway between 1.64 and 1.65. If you add those two together and divide by 2, you get 1.645. So the area, the z-score, and that's how we get that third decimal place. Lastly, we have this one. You can see that it's marked off as the shaded region to the left and to the right. So here we have in between the two is the 0.95, because 0.025 and 0.025 those add together to 0.05, and 1 minus 0.05 is 0.95. So we can look for the z-scores associated with the 0.95 here. So we look at, we need two z-scores, right? So that's going to get us, if we look up on our paper, that's going to give us the positive 1.96 and the negative 1.96 for the z sub 0.025. All right, so our next examples here, obtain the z-score that has 0.95 to its right. I think I made a little typo here. I'm just going to kind of ignore this piece right here. Sorry about that. So 0.95 to the right. So that would leave us with 0.05 to the left. So we look up 0.05. Now that's negative, right? We're to the left of 0, so it's negative 0.05. Then we would find in here somewhere 0.05. Again, halfway between these two. So it's going to be halfway between negative 1.64 and negative 1.65. It's the exact same thing we just did, but negative. So it's going to be a negative 1.645. I want you to try 6.18 on your own. Again, if you have any questions, please feel free to ask me, check in. I'm glad to help.